Hi, I'm an old guy and I do maths, and I want to look at an area of matrices known as adjacency matrices. Now, where you see these are in networks. Um, and if you've had a look through the playlist on matrices, you'll see that matrices do all sorts of things. And um, I keep saying that they're not really a subject, they're a technique, they're just part of the maths scenery. And this is another example of how they're used. So if you look at my first video on matrices, I say that they're tables in which numbers are stored in a particular order. And we're about to see a real example of that here. We're going to take this matrix, this adjacency matrix, and we're going to use it to draw a network. So I'll just get to work here. Everything's in view. So how you read this is those of you who are familiar with networks will know that these are to and from codes here, and so what this says is that there is a link from point A to point A. Now, A in the parlance of networks is what's known as a vertex. And so if we were to draw that, we would draw it like this. We'd simply draw a line that starts at point A here and goes back to A. Now, the thing about this adjacency matrix is that these links, which are called vertices, which are called edges, that's a vertex. An edge is a line that goes between them. These are non-directional. So they don't have arrows on them pointing to particular directions. That's something that's coming up later. Okay, so there's no link between A and B. There is a link between A and C, so we can draw that in. There is a link between A and D, and in fact there are two of them. So we can either draw a second one here, or we can get a bit artistic and do this and draw a link down and around there. Either will do. You don't get points for artistic impression on this. What you get points for is doing the job. There is no link between B and A. We've already discovered that. B does not circle round on itself, so you don't draw in one of these. There is a link between B and C, and we can draw that like that. It doesn't matter that these cross. There's a link between B and D. There is a link between C and A, where we already have that in. There is a link between C and B. We already have that in. There is no circle here around C. There is a link between C and D, which we don't have drawn in, so I'll just draw that in. So that's a single line, very badly drawn. I apologize for that. We have two links from D to A. Those are already drawn in, so we don't need to redraw those. There's a link from D to B, we have that. D to C, we have that. So there's nothing here. So this is now complete. And what I have done is I have drawn a network from the information given to me in this adjacency matrix table. Now, we can put this into reverse. What we would do is we would simply draw up A, B, C, D here, A, B, C, D here, and just analyze what was happening. So there is one from A to A. There is one from A to D. There's a second one from A to D, so that would be 2 there. A to B, there's nothing. A to C, there's 1. And you can see all that there. That is how this works. And this leads into 1- and 2-step dominance, and the use of directional arrows here. But this is where it starts. And as the topic expands, you'll see that there are links between matrices and networks. Anyway, this is where it starts. I hope that was useful. If it was, please like and subscribe, and I'll see you next time. Bye.